Okay, so I'm going to walk through another solution to the previous rock, paper, scissors program. And this is to give you some insight into different ways of handling conditional statements, which is the subject of Chapter 5. So here I have it. This is exactly the same problem as I posted before. I just changed it to Module 4 Stretch Redone. And so I'm just going to go ahead and go over here to my work. And I have nothing to begin with. So what I want to do is I'm going to start with my solution from the last video. And we'll discuss some of the issues with that. So let me just make sure I have it pasted right, and it's going to run. All right, so it passes all the tests. All right, and the structure is basically this. If P1 is whatever and P2 is whatever, then here's the solution. But then look what happens next. Even though that's already been handled, then this has to be tested, and then this has to be tested, and then this has to be tested, and then this has to be tested, etc. So it continues on testing all of these items, even though you've already resolved the answer. It doesn't just jump to the end because it has no way of knowing that one of these other ones isn't also true. So because because there's only one possibility for each of these. In other words, it's either this answer or this answer or this answer, etc. Then there's no reason to retest all of these things. So one construct that that we can easily implement here is the else if. Now officially there is no else if in C++. It's actually an else followed by an if. But because of the way the language is structured, you can do this way, and if I've done everything properly, this should run, or run and pass. Right, so it passed all the 9 tests. And one of the advantages to this is I can also add an else at the end, which would do something like this. Ack, error of some sort, right? Now, that's not going to happen with the data set that I'm using here. But let's say that when I did all of this, I accidentally made this a lowercase p instead of an uppercase P. Now let's rerun it. So look, we have here in running test 5, we have ACK, error of some sort. And so we look over here at the output for test 5, and we see it's chooses, let's see, player 1 is, so it's an S and a P. And we go back over here and we go, there's an S. Oh, wait, there's my error right there. So by having this else if construct like this, what you can do is you can make sure only one of these executes, and then by putting this else at the very end, you can make sure at least one of them executes, right? And that way, if you've accidentally mistyped a situation, now because you know in real life your goal is not just to pass my tests, right? You have to pass real life. And so if there's an actual situation, and then you might end up putting an error in there by making that a lowercase p, and if you did not have this on there, then you'd think it worked right or whatever, or something, you know, it would what's called fail silently if we don't put this in here. It just won't have any output at all, and that will look really weird. So this construct, this if, else if, else if, else if, else if, else if, else, is very, very common construct in programming. And it's very useful if only one of these situations applies, because once I hit one, if this is true and I execute this block of code, the program won't even test the rest of these lines here, including this last else, because it's already found one that matches. So none of the rest of these will be executed, and that will also save execution speed. So that's a very useful construct to use, and I hope that you can make use of it.